Chapter 2, Section 1, Writing and Graphing Inequalities. Chapter 2 is all about inequalities. The first section, obviously, writing and graphing. We'll get into solving here in the next few sections. One vocabulary term for now, inequality. Basically, it's a mathematical sentence that two expressions are not equal. If they were equal, then it would be called an equation, and we worked with equations in Chapter 1. Okay, so with inequalities, there are four symbols that we're going to use. Hopefully you've seen these before. There's the first one. This one is less than. Okay, and how I remember it, I kind of make an arrow, and it's pointing to the left. And I know less than starts with L, left starts with L, so less than points left. That's how I remember the difference between less than and what we're going to see in a second is greater than. When you're seeing phrases with, I'm going to rewrite that, less than. When you're seeing verbal phrases with inequalities, less than is very common. The other common phrase that you would see is fewer than. Fewer than. Okay, those are the two main phrases that come up with when describing less than. Second inequality symbol is greater than. Greater than. Greater than. Okay. Obviously, it's pointing the other direction, the opposite of less than. The other main phrase with greater than is more than. Greater than or more than. Okay, the third inequality symbol, less than or equal to. Okay, let's write this a little smaller. Less than or equal to. Okay, there's no way you could be less than and equal to, but you could be less than or equal to. Okay, two other phrases that go with less than or equal to, at most. So if I can have at most 7 people in my car, that means I could have 7 or fewer. I couldn't go over that. The other one would be no more than. No more than. Like I said, if I can have no more than 7 people, I could have 7 or less in my car. Okay, so less than or equal to, at most, or no more than describe less than or equal to. The final inequality symbol is greater than or equal to. I'll write that here. Greater than or equal to. Greater than or equal to. Okay, just like with less than or equal to, there's two other phrases. We could have at least. Okay, if I need at least 4 people to make up my committee, I could have 4 or I could have more. So equal to is the at least 4 or greater than, obviously. And then the other one, no less than. Whoops. No less than. So think about if I need, that's an A by the way, no less than. If I need no less than 4 people in my car to be in the carpool lane, I need 4 or more. Okay, I could have exactly 4 or I could have more than 4. Okay, so those are the 4 main inequality symbols: less than, greater than, less than or equal to, or greater than or equal to. Okay, so let's try to do some translating here. Write each sentence as an inequality. So the first one here, a number C plus 9.4 is greater than or equal to -6. So what I see right away, I see greater than or equal to. So I'm just going to put that sign right there. Okay, on the right hand side of that greater than or equal to, I see -6. So I'm going to make this -6 on the right hand side. Try writing that a little cleaner. -6. And then on the left hand side, I see a number C plus 9.4. So we'll have C plus 9.4, and then we've got it's greater than or equal to -6. That's your answer right here. This one right there. C plus 9.4 is greater than or equal to -6. Pretty straightforward. Number 2, 6 is greater than a number P minus 8. Again, look for the inequality phrase, is greater than. Okay, so that's greater than. On the left-hand side, I see the number 6, so we'll have 6 is greater than. And then we've got a number P minus 8. So P minus 8. Number 3, it's -7/10 is at least twice a number K minus 4. All right. So is at least, let's go back. Which one is at least? And I see at least right here, which was greater than or equal to. Okay, so at least means greater than, oops, I'll go back to the pen, greater than or equal to. We can put the left side in, negative 7/10 is at least twice a number k minus 4. So twice a number k means if I asked you how old you were and I said what's twice that number, you would double it, take it times 2. So we'll have 2k, and then we've got minus 4 after that. Number 4, 10 is no more than the sum of 3 times the number y and 4. What I look for first, the inequality symbol, is no more than. No more than. If we go find that one, that's right here, with less than or equal to. Okay, so let's go back to the page here. Is no more than, so we'll have less than or equal to. Left-hand side, we just have the number 10. And then the right-hand side, the sum of. So the sum means plus, and really what you're looking for is and. That's where the plus goes. Okay, so we'll have 4 on the right-hand side. Sum of 3 times a number y. I'm going to change colors here. 3 times a number y, that means 3y. Okay, the sum of 3 times a number y and 4. So whenever you see the sum of, and if it gives you, obviously you'll have 2 parts to that, look for the word and. That is your key. This word right here, and, that's going to tell you where this sign goes, the plus sign, or if it was the product of, or the difference of, or the quotient of, the word and is where that sign is going to go, and then it will split up the individual parts of the expression around it. Okay, so let's move on. We got a vocabulary term here, solution. Solution is simply a value that makes an inequality true. Okay, does that mean you're going to have the same number on both sides when you're done? Not necessarily, because we're talking inequalities. There's lots of different ways that we can make a true statement. Okay, so the question here for the example, is negative 6 a solution to the given inequality? So we're going to take negative 6 and we're going to plug it into our variables. Okay, let's start with the first one. C plus 4 is less than negative 1. So we plug in negative 6, so negative 6 plus 4 is less than 1. Negative 6 plus 4 is negative 2. Less than negative 1. Is negative 2 less than negative 1? Well, if I look at a number line, negative 2 is to the left of negative or positive 1, so this is in fact a true statement. So your answer here is yes. It is a solution to the inequality. Let's try number 2. 10 is less than or equal to 3 minus m. So 10 less than or equal to 3 minus our value for the variable is negative 6. This minus sign here does not replace the negative in front of the 6. Okay, so it's 3 minus our value for the variable, which was negative 6. So it's going to be 3 minus negative 6. When you have double negatives, that's like adding the opposite. Keep change. So we got 10 here, less than or equal to 3 plus 6. So 3 plus 6 is 9. Is 10 less than or equal to 9? Well, it's not less than, and it's not equal to, so the answer here is no, not a solution to the inequality. Don't want to put no solution there. We want to put not a solution or just no, because the question is asking, is it a solution? By saying no solution, then it doesn't really make sense, because that's not really what the question was asking. It's more of a yes or no question. Okay, number 3, 21 divided by x is greater than or equal to negative 3.5. So we're going to plug in 21 divided by our x value of negative 6 is greater than or equal to negative 3.5. If you take a calculator and actually do 21 divided by negative 6, what you're going to find out is that that is equal to negative 3.5, greater than or equal to negative 3.5. So what I've got is I've got the same number on both sides of the inequality sign. Is this a true statement? Well, if they're the same number, they're not going to be greater than. But this line underneath it here with the or equal to, that means it's an option that they could be the same thing. Okay, so this one here is a true statement. This is a yes. Now, let's say, kind of going off on a tangent here, let's just say I had negative 3.5 is greater than negative 3.5. If I don't have the or equal to sign underneath my inequality, this would be a false statement. Negative 3.5 is not greater than negative 3.5. It's equal to, but not greater than. So if you had something like this, where you had the same number on both sides, without the or equal to part, this is a false statement. Okay, this would be a no to the answer, or to answer the question, is it a solution? This would be a no. But since we had in our original problem the or equal to symbol right here, that means we're allowed to have the same number, which makes it a true statement. So negative 6 is a solution to that inequality. Number 4, 4x minus 25 is greater than negative 2. So we'll plug in our x value of negative 6. Minus 25 is greater than negative 2. 4 times negative 6 is negative 24. Minus 25 greater than negative 2. Negative 24 minus 25 is negative 49. Greater than negative 2. Again, if you look at the number line, negative 49 is much farther to the left than negative 2 is, and any number, or the number that is farther left, is the smaller number of the two. So negative 49 is not greater than negative 2. It's much smaller, so this one is a no, not a solution. All right, last page here, solution set. A couple more vocabulary terms. The solution set is just all the solutions of an inequality. Okay, in these examples back here, the ones where we had yeses for answers, is negative 6 the only solution? By no stretch of the imagination, it's not. Okay, negative 6 is not the only solution to those two inequalities. There are infinitely many. Okay, but the solution set describes all of the solutions of an inequality. We can show that visually by graphing it. Okay, the graph of an inequality shows the solution set on a number line. Okay, these notes here below this vocabulary term, this is kind of some notes on when you make your number line. Okay, when you make your number line, I want to see even and consistent numbering. I don't want to see something like you go like 2, 4, 7, or negative 2, 4, 17. I want the spacing to be the same. I don't care if you count by 2s or count by 4s or count by 1s or a half, it doesn't matter, as long as you're consistent. So if you want to go 1, 2, 3, perfectly fine. Or if you want to go like 1.5 to 2.5, perfectly acceptable. Okay, the key is just be even and consistent. It could vary from problem to problem. If you want to go by halves on one problem and then by 5s on another, that's fine. As long as you're consistent and obviously number them so that the smaller numbers are to the left. If you have a strictly less than or strictly greater than inequality symbol, that means you're going to have an open circle. Okay, you're going to put an open circle on your specific number. Okay, what an open circle says is that, and we're going to do some shading here in a little bit. Basically, the open circle says every number up to this number is a solution without this number. Okay, the open circle kind of excludes that value from being part of the solution set. If you have a or equal to part, this part, the or equal to, less than or equal to, or greater than or equal to, what that means is now you can include that number and you're going to have what's called a closed circle, or basically you just fill in the circle and then you go from there. Okay, now it says you can have that number that is a solution. Okay, so let's try a few here. Graph the inequality. B is greater than negative 8. So I'm going to come up with a number line. And when you make number lines, I don't need to see a whole bunch of hash marks. Really, 3 is good enough for me. I usually put the value that I'm starting with in the middle, and then the bigger one obviously to the right, smaller one to the left. Remember, with negatives, it's backwards. This is going to be an open circle because I do not have the or equal to part. It's strictly greater than. Okay, so I'm going to have an open circle at 8. And then basically what this sentence is saying is that all numbers bigger than negative 8. And on a number line, bigger numbers are always to the right. So if I wanted to make a mark at negative 7, that would be acceptable. If I wanted negative 7.5, that's acceptable. What you would find is that eventually, if you stepped away from it, you would see just a bunch of lines, or the dots would be making a bunch of circles, or sorry, the dots would be making a line on the number line. Okay, so what we need to do, we're basically going to bold in the one side of the number line, and then we're going to make a bold arrow on the end of the number line. What the bold arrow shows is that the pattern goes on, or there's more solutions farther this direction, forever in this direction. But rather than having to graph them all, we just bold in the number line and go from there. Okay, let's try another one. 1.4 is greater than or equal to G. Okay, so I'm going to get my number line here. 1.4 will go in the middle. 1.5 here on the right and 1.3 on the left. I'm just going by tenths. Just seems most logical to me. At 1.4, I'm going to have a closed circle because it's or equal to. And then this says, if you read it backwards from right to left, it says G is less than or equal to 1.4. or 1.4 is bigger than or equal to g. Basically, this says g's have to be smaller than or equal to 1.4. So really, we're actually going to be going this way. So if you picked 1.3 and put that in your inequality, 1.4 is greater than or equal to 1.3, you would find a true statement. Okay, if you use 1.5, 1.4 is greater than or equal to 1.5, then you've got a false statement. Okay, so if you're ever not sure which way the arrow is supposed to go, pick a number on either side of the circle and put it in. See if you get a true statement or a false statement, and then if you get a true statement, that's the proper side to shade. If you get a false statement, obviously shade the other way. Number 3, r is less than 1/2. So we'll come up with a number line again. And again, this makes most sense to do by halves, 0, 1/2, and 1. This is going to be an open circle because it's strictly less than. I don't have the or equal to part. R is less than 1/2. Then the smaller numbers, because we're still talking about less than, smaller numbers go to the left, and again, bold in your arrow. And then the last one, v is greater than or equal to the square root of 36. Square root of 36 is a nice number. If you're not sure what square root means, basically we're looking for what number times itself gives you 36. And that answer there is 6. So v, we could think of this as v is greater than or equal to 6. And we'll think about it that way. So when we make our number line here, 1, 2, 3, we'll put 6 in the middle, 7 on the right, 5 on the left. This is going to be a closed circle because we have the or equal to part. So we'll make a closed circle, and then it says v is greater than 6. So we need all numbers bigger than 6, or bigger than numbers are always out to the right. Now, if, well, let me point something out here. If your variable is on the left, like 1, 3, and 4 were, notice how this sign is kind of pointing to the right, and the arrow goes to the right. This sign was pointing to the left, and the arrow was pointing to the left. This sign pointing to the right, this arrow pointing to the right. The point I'm trying to make is if your variable is on the left, and I'll write this down, if the variable is on the left, okay, if the variable is on the left, your sign and arrow point the same direction. Point the same direction. Okay, so in 1, 3, and 4, the variable was on the left-hand side of the inequality. 1, left, left, left. Sign pointing right, arrow pointing right. Sign pointing left, arrow pointing left. Sign pointing right, arrow pointing right. Okay, so if the variable is on the left, the sign and arrow point the same direction. Then conversely, if the variable is on the right, then your sign and arrow go opposite directions. Okay, so just something to keep in mind. If the variable's on the left, the sign and arrow are going to point the same direction. Might be something to keep in mind as you start graphing this. And we'll be graphing inequalities quite a bit, so we'll get plenty of practice graphing inequalities.